Welcome back, everybody. Here we are at the 7th Annual IoT Device Security Conference. Hopefully, you are coming from the previous session, which was called Cybersecurity, What It Is and Why You Need It. And you should certainly have attended the keynote address before that, which was delivered by Dr. Lily Chen of NIST. If you missed either of those, they will be available in an on-demand format very shortly. The session you are attending now is called Marrying AI and Security. My name is Rich Nass, but you probably know that because you've been in the other sessions, which I have been the moderator for. I am also the Executive Vice President of Open Systems Media. I lead the embedded IoT teams for embedded computing design. And that's the group that puts this event on. If you're not familiar with ECD, I encourage you to check it out. It's filled with everything an engineer or developer needs to know to design an embedded system. You can find it at www.embeddedcomputing.com. So our expert speaker for this session is Sri Shekhar. He is the co-founder and CEO of Pantherun. Sri has a long history in the cybersecurity space, as well as in embedded product design. His full bio is on the console if you'd like to read it. In the interest of time, I won't read the whole bio. Also note that the conference does continue after the session. We are not done yet. There is one more session at 3 o'clock Eastern time where we cover ensure the security of your life-critical devices. Before we get started, let me go over some of the housekeeping items. The presentation will be somewhere in the neighborhood of 30 minutes, and that'll leave us some time to answer your questions when we're done. And we will answer as many as we have time for. You'll find on the right-hand side of your console a window where you can enter your questions in real time. And as I said, we'll answer as many as we can when Sri is done. If we don't have a chance to answer your question, Sri will get back to you after the session is over with an answer. If you have a problem with the operation of the console, like if the slides aren't advancing right or the audio doesn't sound right, put that into the question box and one of our tech folks will get back to you with a fix. There's a tab there that says handouts. If you click on that, you'll be able to download a copy of the slides that Sri is presenting. You'll also see a link to registration for some upcoming events that you might find interesting. This webcast will be available in archive version as well shortly after we're done. So if you missed it, if you missed part of it, if you want to go back and review, or if you want to send it off to a friend or a colleague, it'll be there for you. For a full screen view of the presentation, click on the expand arrows that are located in the upper right corner of the slide viewing area. To exit the full screen mode, just press the escape button. Finally, I need to thank our sponsors because we can't do these types of events without them. They are Crypto Quantique, Pantherun, the IoT Global Network, the Trusted Computing Group, and Star Lab Software. Okay. Let's bring the star of the show out to get us started. Sri, take it away.
Hello, everybody. This is Sri. Yeah, Rich, thank you very much for the introduction, and thank you all for being part of this webinar today. Yeah. So what we are here to talk about is bringing AI to security and particularly embedded systems, and IoT, since this conference is all about IoT and edge solutions. Yeah. So we're looking to take AI and programmable silicon like FPGAs, and build out quantum resistant real-time protection for embedded systems on the edge. Yeah. The aim is to build solutions that can evolve over time, react to different types of cyber attacks and protect the device in question. So what's happening on the embedded systems and the edge space today? This is a data-driven world. Yeah, AI is reimagining the edge. It is moving into the edge. Decision making and edge computing is happening using AI. Yeah, so that's a significant change for the edge. And so what we're proposing is we also use AI to counter cyber threats on the edge, because the edge needs protection. AI runs on data on the edge, and all of this data needs protection. So we're proposing ways in which we can use AI to continually evolve and protect the edge better. Uh, when you look at AI today, it can provide real-time protection by adapting and responding to security measures. Yeah, and also build out unique security measures on embedded systems. So, what is an embedded system? What are the constraints that we have to work with? An embedded system is typically a resource-constrained environment. Yeah, we all work with edge and IoT devices. They don't have lots of processing power. They typically don't have a lot of memory. They need to work in low power mode. So there's significant constraints when you need to pick a method of protection. Yeah. And unfortunately, this is also the weak link, the edge, because less than 2% of edge devices have any form of protection. So cyber threats are significant challenges. There's the man in the middle type of attacks. There's replay attacks. Quantum computing also is coming on, and that's going to provide a lot of challenge. And the edge needs to have a much better approach to protection, and AI offers that option. And edge is also something that needs to work in real time. It handles mission critical data. So these are all things that we need to take care of when we're trying to protect the edge using solutions like AI. So when you look at AI in embedded system security, yeah, what are the ways in which it can help? It can provide real-time detection. Yeah, so it can identify threats in real time. Yeah, it can do anomaly recognition. Basically, it can look for unusual communication happening across the edge. It can look for unusual loading of the system. So all of these can be recognized using AI. Yeah. And it can provide protection, an evolving form of protection, what we call adaptive protection. Yeah. So AI is able to improve the method of data protection, encryption, and so on as it sees different kinds of threats. Yeah. And AI is an automated system, so it can automatically react in real time to the threats. So it detects an issue, it detects it in real time. It can also react to it in real time. So these are the benefits of using AI on the for security. So now let's look at how anomaly detection happens. When initially the AI models are trained to recognize normal network traffic, identify patterns that are recognizable. So that's something that the AI model is trained to do. Yeah. Then it continues to analyze the data in real time to check for any deviations from this normal network traffic. It also learns from any of these deviations. And when the deviation happens, it immediately flags it as a deviation. So all of this is done by the AI algorithms. Yeah. Now, when you look at the device level, okay, AI can also work at the device level. It can identify how a device behaves, what are the patterns in which the devices behave with each other. Yeah. So all of this AI can study and learn from. Yeah. And it can identify how the behavioral changes are happening from established patterns that it's already learned. And it can also flag these kinds of deviations as security alerts that need to be acted upon. So these are all the ways in which AI can be applied in devices and systems. So now let's discuss adaptive a little bit. Yeah, there's data protection that AI can enable to tackle real-time threat scenarios. It can be used in telecom applications wherein encryption level scale dynamically in response to threats. So if there's any threat that happens, you can enhance the encryption levels. You can add certain extra protections to data. Yeah. And in industrial IoT, it can also work in real time to adjust protocols, adjust how communication happens to maintain greater levels of security. So these are all ways in which AI can help the uh, um, adapt to whatever threats that are happening around it. So how does threat response happen? Yeah. Firstly, is threat detection. AI models identify potential security breaches in real time. I mean, they keep monitoring traffic, they keep monitoring device behavior, and they identify what are the risky situations where a breach can happen. They also can initiate any predefined security measures. So if you define within the algorithm saying under these conditions, this kind of protection needs to be triggered. All of this can be triggered in real time. Yeah, and it can also identify if any device is compromised, or if an anomalous entry has happened through a certain device, that device can be isolated on the network. So again, it can actually modify how network communication happens in case there is a node on the network which is on a ring, that is identified as a compromised node. Data can eliminate that node and pass through the other section of the ring. So there are multiple ways in which AI can be taught to protect against such systems. So let's look at a little bit at training of models for threat detection and response. Yeah, so initially, what happens? Initially, we collect data. Yeah, so we collect things like network logs. We collect how devices are interacting with each other, how frequently they're interacting with each other, what kind of data is passing between devices. Okay, whether there's forms of encryption there. If so, which forms of encryption are there? There could be, some devices using IPsec, some devices using DLS, it could be MACsec, and so on. So all of this is identified, and any deviations from this are, or possible deviations from this are also logged as threat patterns. So all of this data collection happens. Okay, then you identify within data what would be qualified as clean data. We label what kind of situations would be threats, and then we extract also important or relevant features or key features from all this communication. So this is called the pre-processing stage. Okay, then based on all of this, you need to pick a model. Okay, one of the AI models, something that's lightweight, that can go into the resources that your system has. So that's the next step in the process. And then you take the model, you train it on the data, you test it for accuracy. Yeah, you have to maybe add more data to improve the accuracy, and ultimately you minimize the false positives or the false triggering of alarms. So this is how you train the model. And let's go into some examples of, AI which is suitable for resource constrained systems. One key model is a decision tree. Yeah, this is a very efficient ML model that can be used. It's very good for key generation. It's very good for identifying and zeroing in on anomalies on the network. It's a good model for varying keys dynamically in an encryption process. Yeah. Then you have rule-based systems. These are very simple systems wherein you define very clear rules for what is clean data and what is a threat, and it will work in real time to segregate all those threats. So this is another model that can be used. And then there are anomaly detectors. There could be some sort of neural networks and so on, which can also be used to detect anomalies on networks, just like a human brain would. So these are all the models that are ideally suited for uh, for devices with less resources, devices which go into edge networks. So let me talk a little bit about what Pantherun offers that would enable you to work on technology better. We offer the ability for you to use a quantum resistant decision tree algorithm. Yeah. So how does this decision tree work? Firstly, yeah, it works to generate unique keys. So every packet can have a unique key generated using the decision tree algorithm. There is no need for a key exchange. Yeah. Now, when you look at embedded systems today, okay, the reason why encryption is not popular on embedded systems is typical encryption protocols are quite heavy. Yeah, they don't fit on embedded systems. Yeah, they also require a key exchange before encryption starts. Yeah. Now, we have implemented a decision tree algorithm on which generates keys dynamically. Yeah, at the source, data is encrypted, and then a unique key is generated at the destination for decrypting data. So what this means is that there is no key exchange at all. Yeah, this is a key exchange is a very critical necessity or an input to a hacker to be able to break the encryption. Without a key exchange, yeah, the hacker has no inputs to break the encryption. And we've using this AI ML algorithm called decision tree, we have eliminated the need for a key exchange. So this is an example of how you can use AI within the data protection space of embedded systems. Yeah, and this is a very, very compact algorithm. So we are able to put it on embedded devices which are small, which run processors lesser than 200 megahertz. Yeah, we are able to put it on small devices like FPGAs, low power FPGAs, and build out this technology. And we provide this kind of a, key exchange free implementation of AES. Yeah, and this is ideally suited for resource constrained edge devices. Yeah, and let's look at a decision tree. What are the benefits of using a decision tree? Yeah, I mean, it's a tree structure, so it's a very, very efficient structure where you do not need to parse all of the data. You need to parse just the path that you need. Yeah, so the decision making is process is very hierarchical for key generation. It's not you don't require to process a lot of data to generate the key. Yeah, the each node and its weighted path contributes to the final key. So it's a very, very reliable and repeatable process for generating keys and generating unique keys with received data. Yeah, and the tree path can go on changing depending on real-time conditions, depending on the type of data that's flowing between a source and destination. The tree structure can go on changing. So it's a very difficult structure for somebody listening in on the network to be able to replicate. So you can eliminate, quantum attacks. You can eliminate man-in-the-middle attacks. You can eliminate replay attacks. So it's quite quite a good example of how AI can be implemented in security and protect against typical attacks that you see on networks. So, what are the real world applications of Pantherun's algorithm, as well as similar AI algorithms that you will see. Yeah, it can secure machine-to-machine communication, so industrial IoT, networking, yeah, and so on. It's ideally suited for. Yeah, it's also quantum resistant, so vehicle or robot to infrastructure, or in-car and in-robot communication. All of this can be protected with these kinds of algorithms. Yeah. You can protect real-time patient data in medical IoT, yeah, and connected medical devices. So these are all significant areas where you can build in such AI models, or even license that these kinds of AI models from Pantherun. Now, let's go into another aspect that improves security. Yeah. Now, if you use an ASIC with AES implemented on it, yeah, there's a limit to how much the encryption can evolve, how much the key management can evolve. Okay. So we suggest also using another variation like an FPGA, yeah, along with AI, yeah, to build embedded security. FPGAs today are available low cost. They are available low power as well. Yeah, so they can be built into your designs. Yeah, and they can allow you to evolve your encryption on the fly. So you see a certain type of attack, your AI model detects that attack. Yeah, and the FPGA can reconfigure itself. Yeah, to protect and encrypt better, or thwart the attack. So I mean, I think FPGAs are a good option for building into embedded and IoT products, particularly where you want to do data protection or anomaly detection. Yeah, because and they're also very high performance. There's a lot of parallel processing that's possible on FPGAs, which unless the ASIC is designed for it, you won't get. So, and FPGAs have some of the best communication transceivers. So extreme lower latency, high throughput is possible on FPGAs. And I mean, the advantages of FPGAs in edge-based AI security, scalability. Yeah, they can over the life of the product, you can continuously evolve the protection, evolve the way in which you detect threats. So all of this is possible on an FPGA. Yeah, it increases total cost of ownership because every time a new attack comes in, you do not need to throw away the hardware. You can build protection for it, so TCO is reduced. Yeah, and they're very resource efficient. They work. They can do very high throughput without compromising on the power consumption, or compromising on the security. So these are the benefits of using an FPGA based edge security. I mean, edge based AI security. Now, we also help you a little bit in Pantherun in building out solutions like this. Yeah, we have an open source platform which is called Pepper. You can find out more about it at pepper.pantherun.com. Yeah. This is a platform that is open source. It comes with an FPGA development kit. Yeah, it comes with multiple network interfaces, all working at gigabit with PoE. Yeah, it comes with a 4G connection, comes with Wi-Fi, comes with option of 5G, comes with GPS. Yeah, so this is a platform that we provide to our customers as open source. So you can take the platform, you can build out your hardware with it. You get all the drivers for it. You get all the schematics in Gerber. You get also the FPGA internals, including all the network stacks. So you can build out a comprehensive IoT system, a small one, or extendable to multiple ports, multiple IOs, and so on. So this is all available to you, and the encryption technology interoperates with IPsec, TLS, MACsec, and so on. So it's something that's ready to use, that you can either use as an independent product or you can build into your existing product and enhance the security using AI. So how does this accelerate your effort? It's a plug and play framework for easy incorporation of our IP into your designs. Yeah, you can tailor security features for specific applications. So you have an FPGA which can accelerate it as well, and you can put in AI models on it as well, and enhance those. Yeah, and it's proven hardware. It's industrial grade hardware, so it's something that can rapidly improve your time to market if you're building an IoT sensor, robot controller, or automotive device. So I mean, when you look at the advantages you have, I mean, you have AI on FPGA. We give you technology for quantum resistance as well. Yeah, and it's something that's built for edge embedded systems and devices that can be resource constrained. Also, we have a pure software implementation that you can put on your servers on the cloud, and it would give you end-to-end protection for data. Yeah, it's also very flexible. Yeah, because it's FPGA-based, it is open source, and we give you all this technology for you to use. Yeah, and it is future-proof because AI will allow you to continue to evolve your protection against threats. Yeah, FPGA will allow you to continuously reinvent your hardware to do more. Yeah, and we already provide you technology that is quantum resistant. Yeah, so it is quite future proof. And when you look at the way AI is headed, okay, I mean, the emerging trends are trying to make systems more quantum resistant. Markets are significant. They're like medical, industrial, robotics, defense, aerospace, automotive, communication, telecom, smart cities. These are just a few markets. There are so many more that you can take AI in, and you can take that to protect data, protect networks, protect communication. And I mean, as you I mean, you can continue to improve the AI algorithms. You can enhance them. You can add new algorithms as you go along as well, and they will continue to help you protect networks. And I mean, in conclusion, AI has a very important role to play in securing embedded systems or systems that are on the cloud. So end-to-end communication. It's a very big role for AI, and it's continuing to evolve as well. So it will only keep getting better. Yeah. And Pantherun's approach is, I mean, as I gave you an example, use decision tree, use FPGAs, accelerate your development if you wish, with also our open source platform called Pepper. So, I mean, we're open to, I mean, your thoughts and questions.
Thank you very much, Sri. Good stuff. We do have a bunch of questions, so hopefully you're up to this. Okay, ready?
Sure.
Okay. It seems that the processing suggested is made in the network/cloud. Is that correct?
Yes. You can do it on edge devices on the network. You can also, I mean, build it into your cloud application or your cloud server, and you will get end-to-end encryption.
Okay. Does the key generation rely upon truly random sourced input? If so, how do the sender and receiver sync up without a key exchange?
This is a very good question, Michael. I mean, when what we do is we maintain a bucket of past data at the source. Yeah, that is used as the seed for the decision tree to generate a unique key. From that key, we generate IB blocks, and those IB blocks are used to encrypt subsequent packets. Once the subsequent packet reaches the destination again has a bucket of past data that it has received before. Yeah. So from that, we run the decision tree algorithm, follow the same process for a key, follow the same process for an IB block, and then do the decrypt. So all you see between a source and destination is encrypted data, but once it reaches the destination, it gets decrypted. At the source, you have decrypted data. This flows into the bucket at the same time that the decrypted data at the destination flows into the bucket. So it's a FIFO bucket that keeps replenishing. So every time you run the decision tree on the replenish bucket, you get a new unique key. So this is how we are able to keep the two buckets in sync without having to exchange any data.
Excellent. What open source is available with Pepper?
We typically have we have all the schematics for the board. We have the Gerber for the board. We have drivers available with full source code for all the interfaces, and you have lots of interfaces there. You have IOs, you have 4G, you have Wi-Fi, you have Ethernet. Yeah, so we have all those drivers available. We have all the boot code available as well. Yeah. And we give you the tools for you to program the FPGA and the compilers for you to build out your embedded application. We also have a UI which we can also provide to you, that you can customize.
Excellent. How do you ensure that there is no latency in data communication while doing AES with Pantherun?
Pantherun has, I mean, look at Pantherun like a programmable Broadcom. Now you get an SoC from Broadcom. It has a whole range of layer 2 and sometimes layer 3 protocols. Now, Pantherun is a source for all of these protocols. We've built all those protocols that typically go into a layer 2 or layer 3 Ethernet switch. Now, what's the benefit of doing this? Yeah, it means we understand these protocols. As data comes in, we parse the data, we find the payload. Yeah, so that is the part that we encrypt. So the packet does not look or feel any different from the incoming unencrypted packet, which is a standard TCP packet. So since the packet size doesn't vary, we are able to transmit it also at the same speed. So no drop in speed. Yeah. Now compare that with some other forms of encryption today. If you look at IPsec as an example, it takes the whole TCP packet, encrypts the whole thing, and adds its own header and footer because IPsec does not know how to interpret network packets. So the packet's much larger. So if you bring in data at 1 or 10 Gbps like we do, and then you encapsulate and make the packet larger, it's much harder to send it out at the same speed. Yeah. So because we don't change the packet, we don't change the packet size, we are able to consistently send it out at the same speed.
Excellent. Is this AES implementation proprietary, or will it work with other implementations like IPsec, TLS, and so on?
It isn't proprietary. AES is an open standard. Yeah, so we've implemented AES ground up. We've also implemented the typical key exchanges that you will see with TLS and IPsec. Yeah, so we are able to interoperate with both IPsec and TLS as well as MACsec. Yeah, and we have actually customers using our encryption to interact with OpenSSL and IPsec on silicon and so on, and we interoperate very well.
Okay. What kind of maximum throughputs do you achieve with your encryption?
We today focus on speeds at 10 Gbps and lower. So any kind of typical edge or embedded device which communicates at 10 Gbps or lower will be able to use our encryption without any drop in speed. So that's the market that we focus on.
Okay. We are out of questions. Sri, you did an awesome job. You
Thank you so
answered
much.
everyone.
Thank you so much, Rich.
So thank you for a phenomenal presentation. And of course, we can never do these things without you, the engineer, out in the audience. So thank you all for attending. And please stick around for our final session of the day. Ensure the security of your life-critical devices, which takes place in 54 minutes. We will see you then.
Thank you so much.